Hi everyone, welcome back to Lulumath. This video is on function notation, and this is part one of two videos on what function notation is and how to use it. And you'll need to know what a function is, and there's a video at lulumath.com as well as the Lulumath YouTube channel called What is a Function? And it actually ends up using the exact same functions that I'm going to use to explain function notation at first using the function machines. So having watched that video right before this one might be helpful because the functions are exactly the same. So if you remember, a function machine takes some input, which we call x, it does some type of function, some type of rule, and then it gives us an output, which is called f of x. Now, one quick note is that this is not multiplication. This is saying f of x, which is short for function of x. So when we see this notation, we automatically know that we are dealing with some type of a function. So the first example that we looked at in the What is a Function video was having an input here, which we will call x. It can be any variable we want, and we squared it. So our rule was to square it. So we took x and we squared it, and it shoots out some type of an output for us, which is called f of x, but this time we know f of x is defined by the rule x squared. So this is saying a function of x, which is this f of x right here, is defined by, which is this equal sign right here, the rule x squared, which is this x squared that we see here. Now, typically what we normally see, y equals x squared. And remember, our output is y. So if this is our output, we are now saying f of x. So pretty much y is just equal to f of x. So we can take out this y right here and just essentially replace it with f of x instead. And we're saying the exact same thing. So these two things are interchangeable. Now, why would we do that? You're going to see in the next examples that we have coming up what the use is for saying f of x. Now, in another example we had looked at, our input was x. Our rule was 5 less than twice the input, or 2x minus 5, and then it gives us our output, which is f of x. Now, just a quick note, you can use any letter you want. It does not have to be the letter f. So for example, we could use g of x. So here, instead of saying y equals 2x minus 5, we'll simply just say g of x is equal to 2x minus 5. And in our last example, we still have an input of x. And again, you can use any letter that you want. It doesn't have to be x, just like we didn't have to use f for our function. And our rule was the absolute value of 4x plus 3. It gives us our output. Again, we don't have to use f of x or g of x. We can use any letter we want. So here, I'll just use r of x, just because I randomly decided to do r of x. So here we can say r of x is equal to the absolute value of 4x plus 3. Instead of y equals the absolute value of 4x plus 3. So again, just a quick note, the x is our input, the r of x is our output. And I can't stress this enough, this r of x here is not multiplication, it's not r times x. So let's go straight into how to use function notation. It's actually a really convenient notation to use. So here, this is saying if f of x equals 9 minus 7x, find f of negative 3 and explain what the result means. So remember, this x right here is the input, and this f right here is the output. So essentially what this is saying, because this is the input, and this is the output, we are trying to find the output when the input is negative 3. Do you see how convenient this notation is? All of this is summed up in this smaller notation that we see here. So literally, I'm just going to put in my input of negative 3 into my rule, which is 9 minus 7x. So again, we want to try to find the output when the input is negative 3 using the rule defined by f of x. So if f of x equals 9 minus 7x, and my input is negative 3, then every time I see an x, I'm going to replace it with negative 3. So f of negative 3 equals 9 minus 7 multiplied by negative 3. And then all I have to do here is just evaluate. So this is telling me that f of negative 3 is equal to 9. And then here, when I multiply negative 7 by negative 3, I end up getting positive 21. So that means that f of negative 3 is equal to 9 plus 21 gives me 30. So what does this result mean? It tells us when the input is negative 3, the output is 30. When our rule is f of x equals 9 minus 7x. All right, let's type this into Desmos using function notation. So we would say f of x is equal to 9 minus 7x. Notice we have our graph here. It has a y-intercept of 9, and then it has a slope of negative 7 over 1, down 7 over 1. Now I could have written just y equals 9 minus 7x as well, and I would get the exact same graph. But what's nice about the function notation is, if I want to figure out what f of negative 3 is, I just type in f of negative 3 here, and it tells me that the answer is 30 because it knows that when my input is negative 3, we just plug in negative 3 into this equation up here, and we get our output of 30. And if you take a look at what we have here, we have the point negative 3, 30, and it's a point on our graph because when the input is negative 3, the output is 30. Negative 3 is my x value, my input, 30 is my y value, my output, and it is on the graph of my function. All right, in our next example, if f of x equals 9 minus 7x, find f of 1.5 and explain what the result means. Same exact function. Here we have 1.5 as our input, and whatever the result is, whatever we get for f of 1.5, that will be our output. So here, every time I see an x, I'm going to replace it with 1.5. F of 1.5 is equal to 9 minus 7 multiplied by 1.5. So every time I see an x, I fill in 1.5. So now I'm going to see f of 1.5 is going to be equal to 9, and then I'm going to multiply this negative 7 by 1.5, and when I do that, I get negative 10.5. And again, this is f of 1.5. So to figure out what f of 1.5 is, I just do 9 minus 10.5, which is equal to negative 1.5. So what this is telling us is when the input is 1.5, if the output is negative 1.5. So I can go right back into Desmos here, and I can delete this negative 3 here and put 1.5. So now I know my input is 1.5, my output is negative 1.5. So it's the same idea. 1.5, negative 1.5 is a coordinate on the graph of my function. Okay, in our last example with this specific function, it says if f of x equals 9 minus 7x, find x. So this time the unknown is the input. I want to find out what x is when f of x is equal to negative 12. So this time I know my output, and I want to find my input. So I'm not going to replace the x with negative 12. I'm going to replace all of f of x, my entire output, with negative 12. So this will say negative 12 equals 9 minus 7x. And now I just solve for x. So I'm going to get rid of this 9 by subtracting it. And when I subtract it, I get negative 21 equals negative 7x, divide both sides by negative 7, and I end up getting x equals positive 3. So this time what we are saying is when the output is negative 12, the input is 3. So this time the way we would write our coordinate is it would be 3, negative 12. So this time, instead of writing f of some number, I'm going to say f of x is equal to negative 12. And when I look at that, I can see that it intersects at 3, negative 12, which means that my input has to be 3 in order to get an output of negative 12. All right, in this example, we're given a function and it's called g of x. Remember, it could be any letter. The first thing we want to determine is g of negative 1. So here, this -1 is our input, our x value. And we want to find out our output, or our y value. So I'm going to go to -1 on my graph, and here is -1, and when I go up, I can see that this point is on my graph. And this point is telling me that when my input is -1, my output, or my y value, is 1, 2, 3. So g of -1 is equal to 3. In this example, we want to find g of 0. So again, our input, or our x value, is 0. Our output, or our y value, is what we want to find out. So when my input is 0, right here is my input of 0, I can see that this is my point on my graph of my function. And this output is 1. So we can say that g of 0 is equal to 1. And then in our last example, we want to find x when g of x is equal to -1. So this time we are told what g of x is, and that's -1. We're told that our output, or our y value, is -1. And we're trying to find our input. So this is the unknown. So I'm going to go to -1 on my graph for my y value. So I'm going to go to -1 right here, and I'm going to see where is my graph going to hit -1. And it hits -1 when x is equal to 1, 2, 3. So this will happen at x equals 3. All right, in this example, we're asked to determine, first of all, is the relation below a function? So if we look at this here, we can use the vertical line test. And remember, the vertical line test says that if a vertical line cuts through my graph more than once, it's not a function. It's only allowed to cut through my graph once. So like, for example, here, it only intersects once. Here, it only intersects once. Here, it only intersects once. Even here, all sorts of examples of where it only intersects once. But now the question is, looking at what we have here, when I draw my vertical line at -2, I can see 2 different intersection points. However, this is an open circle, which means that the graph is not defined there. So this graph is getting closer and closer and closer to -2, but at -2, the point is not there. So this means it is not equal here. This is a closed circle, so it is equal. So even though when I draw my vertical line, it appears to intersect twice, technically it is not intersecting here, and it only intersects here, which means that it does pass the vertical line test because it only intersects with my graph once. And then if I were to draw a vertical line through here, same thing, it does not intersect here. Say it's still an open circle, it's not equal, but it does intersect here. It's a closed circle, so it is equal. So it still only intersects once. Now this function is not a continuous function because it jumps from one place to the next, but that's okay. That's not required for a function. As long as it passes the vertical line test, it will always be a function. So now that we know that it is a function, and this function is called h of x, we are going to find h of -4 to begin with. So I will go to -4 as x on my graph because this is my input. So here's -4, and when I go down, I can see that it intersects at this point here. So h of -4 is equal to -5. Now I'm going to find h of -2. So again, same thing, this -2 is still my input, or my x value. So when I go to -2, because right here we have an open circle, it is not my output. My output is where my closed circle is. So this right here is my answer to this question, where we know that h of -2 is going to be equal to -1, 2, 3. And then for our last one, h of +1, again, 1 is still our input, it's our x value. I will go to 1, and because this is an open circle, it's not defined there, it is not the output, but this is a closed circle, and I can see that my output is -3. So h of 1 is equal to -3 again. Now the last thing we're asked to do is to determine x when h of x is equal to -3. So this is our output. This is our y value. And I want to determine what is my x value that will give me -3 as my output. So I will go to -3 here on my graph. This is -3. I can see that my graph has an output of -3 here when x is equal to -3 as well. That's just a coincidence. Any number from here, so from -1 all the way to here, all of these values are equal to -3. So from -2 on my x values all the way to 1, I will get an output of -3 here along this line. And then I also have an output of -3 when x is equal to 2. Now you might ask, well, I thought in order for it to be a function, each input should have only one output. So why do I have multiple answers? Because an output is allowed to have multiple inputs as long as each individual input still only gives us one output. So here we have multiple answers. It will work when x is equal to -3. It will work when x is between -2 and +1. And it's included because these are closed circles, which means that they are defined at those points, as well as when x is equal to +2. So this is our solution. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.